With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello. So the question is, we have given consider a situation in which one end of the massless spring of the constant K is connected to a cylinder of mass M and the other rigid supports. When the cylinder is given a gentle push in a horizontal direction, it starts oscillating on the rough horizontal surface. Okay. Now, during the oscillation, cylinder rolls without slipping. Okay. It roll without slipping. Okay, means pure rolling is given to us. Now when the when calculated motion cylinder is found to be S.H.M with the time period 2 pi root 3m by 2k, and the equation is of S.H.M is x equals E sin omega t, where the symbol have their usual meanings. Okay, we know that E is just amplitude. Okay, now here we have given at a distance x1 from the equilibrium position, the kinetic energy of the oscillating system becomes equal to potential energy, then x1 is equal to, okay, so basically first of all we have a cylinder, okay, and it is moving with velocity v and rolling. Let's say here it will also do a rotational motion. Okay, so it will rolling with the omega, and here it, let's say if it is moving at any time, let it move x distance. Okay, so after x distance it is at something here. Okay, it will be at something this place. Okay, here it is moving with velocity v. Okay, rolling with omega, and it will shows pure rolling. For pure rolling we know that pure rolling, we know that v should be equals to r omega, as we know that here in this direction omega r, and here for this point here the velocity v. Okay, for this point if we consider a point here, so omega r is the velocity in the opposite direction, and this, so for pure rolling case v should be equals to r omega. Okay, that's always true. Now here let us try to write the equation for the potential energy as well as kinetic energy. Okay, it will place in a rough surface, so here the friction is also applicable. Now for the potential energy, very first potential energy, so potential energy for the system can be said as half of kx square. We know that for the energy for the spring energy system. Okay, half of kx1 square. And the kinetic energy, when you write the kinetic energy for the system, so it can be written as here half of mv square, which is for translation, and for rotational it is half of I center of mass inertia for center of mass multiply with omega square. Okay, now here basically we have given a cylinder, so inertia for the about center of mass for cylinder is said to be what? It is mr square by 2. So let us put half of m v square plus half m r square divided by 2. Okay, multiply with omega square. Understood? Now from this we can write that here it is half mv square. Okay, now you can see this r square and omega square, as we know that v equals to r omega. Okay, so by using this, okay, v equals to r omega, so by using this we can write that what here v equals to r omega, so you can write v square in place of this. Okay, so let us write here half of mv square plus here 1 upon 2, 1 upon 2 will be 1/4 mv square. Okay, so finally kinetic energy of the system, you can write that 3 by 4 of mv square. This is the kinetic energy of system. Okay, now we have given that the kinetic energy and potential energy are equal, so we can write 3/4 of mv square should be equals to half of k x square. 3/4, okay, half of k x1 square. Okay, it's a x1. Understood? Now, okay, let's say this is equation 1. Now try to find the velocity. Now try to write the velocity and the omega. First of all, let us try to find v. We know that v is what? Basically, whenever we are talking about the velocity in the S.H.M, if the particle is performing S.H.M, so velocity V square can be written as, okay, first of all, the V can be written as omega under root of a square minus x square. Okay, this is the formula of the velocity when we are trying to solve the S.H.M. Okay, so for the V square, it can be written as, let's say it is omega square, and here a square minus x square. Okay, now use this equation. Okay, so put this in equation 1. So when you put this value into equation 1, so it can be written as 3/4 of m v square is omega square a square minus x square equals to half of, let's write it x1. Okay, because we are solving for the first v1. Okay, so half of k x1 square. Okay, you can write this. So now try to find the omega. Omega can be found out by simply saying we have given the time period. Time period is what? Basically time period can be written as 2 pi by omega. So now when you see this, here we have given t equals 2 pi root 3m by 2k. This shows what? The omega will be what? The omega will be 2k by 3m. You can write the omega as 2k by, here from this we can write omega 2k by 3m. This is the value of the omega under root 2k by 3m. Okay, for the omega square we can write 2k by 3m only. Okay, so here write omega equals under root 2k by 3m. So for omega square, let us write 2k by 3m. Okay, under root will be here removed. Now here it will be a square minus of x1 square, and here we have half of k x1 square. Understood? Now we have to only solve it and we will get the final answer. So here you can see this m will cancel out with the m. Okay, here the 3 will cancel this 3, this 2 cancel this 4 2 times. Okay, so we have here half of k, and it is a square minus x1 square. Here we have the half of k x1 square. Okay, from this half k will be cancel out. Okay, so we have here with a square minus x1 square, and here we have only x1 square. Okay, so you can write a square as 2 times of x1 square. Okay, you can write here. So for the value of the x1, we can write the x1 will be a by under root of 2. Okay, this is the answer of our question. Now let us check the option for the a by root 2. Means this option is the correct answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.